In this video, we present PrivacyLens, on-device PII removal from RGB images using thermally enhanced sensing. Cameras are one of the most expressive and information-rich sensors, and they've been incredibly effective at performing important tasks in the home, such as health monitoring, activity recognition, and fall detection. And commercial camera-equipped products exist to do elder care monitoring, baby monitoring, and pet monitoring. However, there are privacy issues with the cameras in the home. First, many users have a mental model that the data these devices collect is for their own personal use. However, there have been numerous incidents that reveal that this is not the case. And the way these systems are designed often makes it difficult to determine who exactly can access their data. The typical IoT pipeline has data leaving the device and going to a server. On this server, both authorized actors, such as the device manufacturer, and unauthorized actors can gain access to the data the user thought only they were privileged to. However, even authorized actors can perform unauthorized behaviors, where sensitive data ends up on social media and public forums. For example, the owner of this camera-equipped Roomba never expected their vacuum to send pictures outside the house, let alone appear online or on social media. So how can we keep the useful parts of cameras while addressing their privacy issues? One way is for the IoT device to have a PII filter on board that can remove sensitive information before it leaves the device and heads off to cloud storage. No matter how secure the cloud is, users do not want to share sensitive data stored somewhere that others could have access to. To tackle this problem, we present our solution, PrivacyLens. PrivacyLens uses a hybrid RGB and thermal approach to remove PII. The thermal sensor is used to help find persons in the environment and create a subtraction mask. RGB is used with a lightweight YOLO V5 model to find persons' bounding boxes. The union of the two regions defines the pixels to be removed in the RGB image. And we can use these capabilities to selectively composite different image representations to offer flexibility between the privacy desires of users and the information needs of downstream applications. This is what some of them look like in real-time video. Here's thermal subtraction, where the persons in the image are removed entirely. Here's stick figure, where only a stick figure representation is captured. Here's Ghost UI, where it adds a silhouette of a person in the image. Here's Thermal Only, where only the thermal image is stored. And here's Face Swap, where only the faces are replaced. But again, all of these need to happen on the device, so let's talk hardware. PrivacyLens consists of three major components: an RGB camera, a thermal camera, and a Jetson Nano, an embedded device that has an efficient embedded GPU. We can use its embedded GPU to accelerate PII removal tasks so that they can happen in real time. To evaluate PrivacyLens, we conducted a deployment study where we deployed PrivacyLens in three environments: an office atrium, a home living room, and a public park square. We collected over 22,000 image sets, of which 3,261 contained persons, the basis of our evaluation. Here we show a time-lapse of the atrium, the home, and the public park square. And here's the time-lapse of the PrivacyLens sanitized versions. We evaluated PrivacyLens against two RGB-only methods, YOLO and Detectron 2. We found that the RGB-only method struggled to remove all 5 forms of PII, only completely sanitizing less than 57.6% of images. PrivacyLens's hybrid approach performed robustly, completely sanitizing 99.1% of all images. There were no total failures and no facial PII leakage. While we have shown that PrivacyLens can remove PII well, we also demonstrate that PII sanitized outputs are still useful and it can support important camera tasks. For exercise tracking, we use stick figure to identify key points, and using those key points, we can count the number of repetitions. For hand-to-object detection, we paired stick figure, thermal subtraction, and a YOLO object detector to determine when a person interacts with an object in the environment. And for fall detection, since fall detection models are very computationally expensive and cannot be processed on device, we can generate key points on device and send only those key points to an off-the-shelf model that we did not have to modify, allowing for privacy-preserved fall detection that can leverage existing ML models that can be safely distributed to the cloud. In conclusion, PrivacyLens made the following contributions: the PrivacyLens system, which performs robust PII removal, and extensive evaluation across multiple environments, showing significantly improved PII removal rates over RGB-only methods, and 3 applications, which demonstrates PrivacyLens's utility and their compatibility with downstream computer vision and ML applications. This was PrivacyLens. Thank you for watching, and please see the paper for more details.